Hello, and welcome to HPE Aruba Networking TOI sessions for AOS-CX switches. Today, we'll be discussing on the feature input voltage monitoring, which is introduced in 10.16.1006 release. My name is Sambit Haldar, and I'm working as tech lead in the Yati team. The input voltage monitoring is used to diagnose any environmental issue that may be encountered by the customer. It is always important to check whether the input voltage to the switch falls outside the operating range of the switch's power supply unit, that is PSU. This enhancement enables the switch to monitor input power voltage and report deviations from the supported range. Following are the new show commands that are introduced in this release, which is show environment power supply input voltage. For the VSF, it is show environment power supply input voltage with the VSF member ID, show environment power supply input voltage events, and the same command with the VSF, that is show environment power supply input voltage events with the VSF member ID. The input voltage is monitored by polling each power supply unit for 5 seconds and taking the reading of the input voltage and preventing excessive state change with the help of trigger and hysteresis value. It is also important to note that the input voltage averaging period is fixed for 15 minutes. Here are the devices that supports input voltage monitoring feature. As you can see, except the fixed PSU model switches, it supports all the SKUs, meaning except 4100i, 6000, 6100, 6200F, and 6300F. All the switch models supports this feature. Also, please note that 10040 switch is supported from 10.16.1010 release onwards. Operating out of input voltages specification may cause PSUs to shut down due to undervoltage, that is brownout scenarios. This is often caused by instability in power source, such as bad or aging cabling. Hence, monitoring PSU's input voltage can indicate and warn user if there is any power source instability in the environment. Despite rated at 100 or 110 to 240 volt nominal voltage range, Aruba PSUs are regulatory required to be able to operate 10% below its normal voltage, meaning 90 volts if rated at 100 volts. These values, plus or minus 10% above or below the nominal voltages, are referred to as the normal range. The PSUs are capable to operate beyond this normal voltage range. This feature is introduced for the demand for need of sustainable and green IT operations, which allows power demon to indicate to the user when input power source is unstable by monitoring, logging, and counting the number of instances where PSU is operating out of normal range. This feature is driven by HPE also to reduce several RMA and outages due to input voltage out of range. We will now go through some key terms that are used in this session for ease of understanding. Input voltage monitoring. It refers to the process of tracking and analyzing the voltage supplied to a PSU to ensure it remains within the specified operational limits. It helps protect the PSUs from voltage related issues and maintain switch stability. Overvoltage. This occurs when the PSU's input voltage rises above the maximum allowable operating voltage, potentially causing damage to PSU or PSU failure. Monitoring for overvoltage is currently not supported. Under voltage, this happens when the PSU's input voltage drops below the minimum required operating voltage, which can lead to brownout scenarios or PSU shutdown. The trigger value is a predefined threshold set to detect and log instances where the input voltage violates acceptable operating limits, enabling timely corrective actions. The hysteresis value is a secondary threshold used to identify when input voltage has recovered from a violation and returned to the safe operating range, ensuring stable operation without false alarm. Please note that input voltage monitoring functionality is enabled by default with fixed trigger and hysteresis values. I would also like to mention that PSU input voltage monitoring functionality is available on our DC PSU platforms with following caveat. The system will reflect under voltage status even when running in normal range of PSU input voltage. This functionality is intended to be enhanced in forthcoming release. Now, to talk on the input voltage monitoring logging, following are the logs that will be generated from the feature. A warn log will be generated when the voltage goes below the trigger value as a violation. This log also indicates when the PSU status changes to under voltage. It will also show the upper and lower bound normal voltage of the PSU. A notice log will be generated when the input voltage recovers to above the hysteresis value. This log will indicate that the PSU status shall no longer be under voltage, and it will also show the upper and lower bound normal voltage of the PSU. An info log on the other hand will be generated when the PSU input voltage monitoring starts for the given PSU. This occurs when the PSU is inserted to the power supply slot or when the PSU input line is turned on. We will now discuss on the show commands that are introduced. It displays the statistics and status for the power supply's input voltage. The following information is provided. The output of the command show environment power supply input voltage will have the fields which we'll see with an example in the next slide. We will discuss all this nomenclature. In this example, input voltage averaging period specifies the period in which the input voltage average is calculated. This value applies to all members in the stack. As I mentioned it previously, it is currently set to 15 minutes and cannot be configured by the user. The MBR/PSU is the identification of the power supply of the system. Product number is for the product identification for the type of power supply. The input type is power supply's input type identification. It can be a AC or a DC one. Normal input in volts, meaning normal operating voltage range for the power supply to support current wattage according to the regulatory operations. Present input in volts, meaning the instantaneous input voltage reading which is acquired from the power supply. The average input means the average input voltage over the last 15 minutes or since power was applied if less than 15 minutes ago. Input voltage violation count number, meaning the number of occurrences for which PSU's input voltage crosses outside the normal input. Input voltage violation most recent event is the timestamp of the most recent violation where the PSU input voltage crosses outside of the normal input. The recovery count is the number of occurrences when the PSU's input voltage recovers to within the normal input range. Recovery time, on the other hand, means the timestamp of the most recent input voltage's recovery. The next command which is introduced is show environment power supply input voltage events. It displays the input voltage violation and recovery event details for a given switch. The switch stores a maximum of 32 input voltage events for each power supply unit. If the number of events exceeds the maximum value, it will automatically delete the oldest event and add the latest event into the system database. In a VSF setting, the command can also be called for individual members of the stack by adding another argument, VSF member, followed by the member name. It displays the statistic and status for the power supply's input voltage. We will go through the information with an example in the next slide. Here, in this command output, max input means the power supply measured maximum voltage. Minimum input means the power supply measured minimum voltage. ID denotes the input voltage event identifier for the each PSUs. Type denotes whether the event is a recovery or a violation. The voltage column shows the instantaneous input voltage reading when the violation or the recovery event is logged. The timestamp shows the time string that denotes within the event occurred. Also, if we issue the command show events minus R minus D power D, it shows us the event details when the voltage went out of the range and recovered back to normal. In the diagnostic mode, we can also view the hysteresis and trigger values by issuing the command diag show power supply as highlighted in the example. Thank you for attending the TOI series. The Airheads community is an online space for technical network professionals, including customers, partners, and the product and solution experts, to connect and discuss everything HPE Aruba networking, including deployment, configuration, troubleshooting, and best practices with their peers. Signing up for the Airhead community takes less than 2 minutes. Please scan the QR code and sign up today. Thank you.